topic is power converter. Power converter is that basically four types of power converters. Power converter is nothing but using a power semiconductor devices. We are going to convert one form of energy to another form of energy. It is basically four types. One is a rectifier, inverter, chopper, AC to AC converter. Rectifier is the first type. It is an AC to DC. We can call it as a rectifier. And inverter is nothing but inversion. Okay, inversion of a rectifier. It is a DC to AC. And the third one is chopper, DC to DC conversion. And the final one is AC to AC. Rectifier converts fixed AC to DC. DC may be variable or fixed. Based on the semiconductor we are using, we can have a classification uncontrolled rectifier and controlled rectifier. Uncontrolled rectifier output is fixed. DC is fixed. In variable output we can have a controlled rectifier. We can say it as a controlled rectifier. The output is a variable one. It is a rectifier. The next one is an inverter. In the inverter is nothing but a fixed DC to variable AC. We can say it as an inverter. And chopper is a fixed DC to variable DC. That we need a required variable DC output, then we can go for the chopper. That is a fixed DC to variable DC. Okay. And the final one is an AC to AC converter. It is nothing but similar to a transformer using a semiconductor devices. We are going to perform a same operation. Input is an AC, output is also AC. We can say it is an AC to AC converter. In that we are going to have a AC voltage controller and cycle converter. AC voltage controller is nothing but input is a fixed AC, output is a variable AC output, and frequency is fixed. Okay, like a transformer, it is going to convert a fixed AC to variable AC. Frequency cannot change, that is AC voltage controller. And cycle converter, input is AC, output is also AC, but we can change the frequency also. Input is fixed AC, output is a variable AC as well as variable frequency. We can say it as a cycle converter. These are the basic power converters. Okay. First, we are going to see in detail about the rectifier types. Okay. In that rectifier, we can say this rectifier is nothing but an AC to DC converter. Okay. In AC to DC converter, we are going to have two types: controlled rectifier and uncontrolled rectifier. Both the cases for controlled and uncontrolled rectifier, we can say it as otherwise we can have a name as a phase controlled or phase controlled converter. In phase controlled converter, we have a single phase as well as three phase. Single phase controlled rectifier and three phase controlled rectifier. In both the cases, we are going to have the semi converter, full converter, and dual converter. In semi converter, we have two controlled devices and two uncontrolled devices. Okay, and for the full converter, all the our semiconductor devices are controlled devices. We can say it as a full controlled rectifier. And dual converter, we are going to have the two single phase converters connected back to back for the single load. We can say it as a dual converter. For the case, same three cases available for the three phase also. Three phase semi converter, three phase full converter, and three phase dual converter. In that single phase controlled converter, again for the classification based on the output waveforms. Okay, we can say it is a full wave and half wave. Okay, full wave or half wave. In both the cases, full wave and half wave, we have bridge rectifier. Okay, bridge type. Okay, bridge type full wave as well as bridge type half wave rectifier there. Okay, and then midpoint converter. Okay, in bridge type, we have a semi converter and full converter. Already we saw the semi converter and full converter and dual converter. Same thing, the semi converter and full converter. Semi converter is nothing but it has two controlled power devices and two uncontrolled power devices. For the case of full converter, all the power devices are the output the two both the positive as well as negative output waveforms. Okay. First we are going to see the full bridge converter. It is fully controlled converter. It has a bridge type. It has a 4 power devices. 4 controlled power devices. You can take a SCRs, that is T1, T2, T3 and T4. It has an input as an AC. It is given to 2 legs of the bridge converter. Single phase AC supply. Single phase AC supply. It has a 50 Hz frequency. Single phase AC supply 50 Hz frequency. It is given to the converter as an input, and load is connected. End of the bridge. First we are going to take the R node. Okay, it has a 4 power devices, thyristors T1, T2, T3 and T4. Okay, it is a single phase full bridge controlled converter. Okay, the operation is we are given a AC supply to these 2 terminals. Okay, the first leg we are going to connect it with the phase, and second leg we are connected with the neutral, single phase neutral line. Okay, and it has a 4 power devices. All the 4 power devices are controlled devices, SCRs. You can say it is a controlled converter. Okay, and the load is resistive load. We are connected to the outer terminals of the rectifier. Okay, now the operation, we have 2 modes of operation. Mode 1, okay, we are going to turn on 2 power devices. During positive off cycle, P is positive and neutral is negative. During positive off cycle, thyristor T1 and T2 are made forward bias, and we can give the pulses to these 2 power devices. And during negative off cycle, and this is negative and this is positive. Okay, T3 and T4 are forward bias, T1 and T2 are reverse bias. We can give the pulses to T3 and T4. Okay, in the mode 1, T1 and T2 are forward bias. We are going to give the pulses to these 2 power devices. Okay, and this is positive. The current flows through the power device T1 and load, and through the power device T2, and current is back to neutral. This is the current flow of mode 1. Okay, after receiving the pulses to the thyristor, the current starts to flow through the thyristor T1, T2 and through the load. Inside is mode 1. In mode 2, this is mode 2, and this terminal is negative and this terminal is positive. Okay, and these 2 devices are forward bias. After the firing pulse, that is we are going to do the pulses after pi plus alpha, these 2 devices are going to turn on. But these 2 devices are going to turn on, okay, the power flows from during second off cycle, this is positive. The current flows through the power devices T3, and this is made forward bias T3, and through the load, and the current is back to T4, and this terminal. This is the current flow of mode 2. For both the modes, current flows through the load in only one direction. Okay, that is why the input supply AC alternating quantity is received in the R node as a single direction. That is a direct current. Okay, these are the 2 modes of operation. Now we are going to see the waveforms single phase full bridge converter. Supply voltage what we are having the input supply. It's a single phase AC supply. Single phase AC supply. Then this is single phase AC supply. And the values of 0, that is a time period. That is a 0, pi, 2 pi and 3 pi. We have a single phase AC supply. Okay. And this waveform is for R load. Okay. The load is resistive load. If it is a resistive load, okay, we are going to have the output voltage and output current. Okay. After the firing angle, we know that we are going to give the pulses to the tires T1 and T2 after the firing angle alpha. At this point, we are going to give the firing angle. After giving the firing angle, the current flows through the T1 and T2. Current flows through the tires T1 and T2 up to the angle phi. Up to the angle phi. After that, what happened? The supply is reversed. We are getting a reverse supply. What happened? The thyristor T1 and T2 are made reverse bias. It is automatically get turned on at this point. Okay. After that point, okay, T3 and T4 are made forward bias. T3 and T4 are made forward bias. We need to give the pulses to the thyristors T3 and T4. We are giving a firing angle at an angle of phi plus alpha. We can consider the alpha is any angle 30, 60 or 90, anything. We are considering it as almost 45. Okay, the alpha is 45. We are getting output up to pi. Okay, and after that pi plus alpha, we are given pulses to the thyristor T3 and T4. After giving a pulses to T3 and T4, we are getting output voltage as the same direction. It is followed the supply voltage of from alpha pi plus alpha to 2 pi. Okay. After that 2 pi, what happened? Automatically T3 and T4 are get reverse bias. It is reverse bias, and automatically it is get turned off. We are going to have any current flow through this. Okay. And this is output current. Output current is as for a resistive load. We are getting the same output current. It is followed by our output voltage. Only thing is the magnitude based on the resistance value. Based on the resistance value, the magnitude going to affect the magnitude. Okay, that is the magnitude of the waveform. Okay, otherwise it is going to get the same output waveform for output current. Okay, the next thing we are going to consider the load is resistive and inductance. R and load. The load is R and load. For the R and load, what happened? The same thing. We are going to give the pulses to the T1 and T2 during positive cycle. These two are the devices are formed by T1 and T2. We are going to give the pulses at an angle of alpha. We are considering now only we are going to give the pulses at an angle of alpha. What happened after that alpha? The current starts flows through the resistance and inductance R and L. Okay, what happened? The voltage we are going to get the same followed by your supply voltage. It is going to follow the supply voltage up to pi. But the current is what happened? The inductance stores the energy initially. Okay, the current start increasing. Flow will start increasing. Okay, and the inductance is fully charged. What happened? The current is going to have the maximum. Okay, once it is going to reach the maximum, what happened? It is reaches the pi. If it is reaches the pi, what happened? The T1 and T2 get reverse bias. It is get automatically turned off. But what happened? The inductance stored energy is as the stored energy. The inductance gives the continuous current. But what happened? The current start decreasing from the pi. Because of the current flows through the load, what happened? Whatever the voltage appear across your load, that is reverse voltage, that will be we are getting as an output from pi to next firing angle. Up to next firing angle. It is a continuous load current. It is continuous load current. It is a continuous load current. Okay. The output is we are going to have the output voltage followed by your supply voltage, and what happens to the current? Current start again increasing. Okay, the energy is stored in the inductance. Once the energy stored is full, we are going to have the current increases in the load. Okay, up to the next value. Once it reaches the maximum at an angle of 2 pi, what happens? Again, we are going to have that is T3 and T4 are getting reverse bias. T3 and T4 are reverse bias. It start turned up. Once the T3 and T4 are turned up, the current stored energy in the inductance gives the continuous current. Because of the continuous current, the current is start reducing, but the load current is flowing. Okay, because of that, we are going to get the negative supply. full bridge converter or single phase full bridge controlled converter. We can say it as a two pulse converter. Two pulse converter means it has a two pulses. You can get the output in the two, both the positive as well as negative output waveforms. Okay. First we are going to see the full bridge converter. It is fully controlled converter. It has a bridge type. It has a 4 power devices. 4 controlled power devices. You can take a SCRs, that is T1, T2, T3 and T4. It has an input as an AC. It is given to two legs of the bridge converter. Single phase AC supply. Single phase AC supply. It has a 50 Hz frequency. Single phase AC supply 50 Hz frequency. It is given to the converter as an input, and load is connected. End of the bridge. First we are going to take the R node. Okay, it has a 4 power devices, thyristors T1, T2, T3 and T4. Okay, it is a single phase full bridge controlled converter. Okay, the operation is we are given a AC supply to these two terminals. Okay, the first leg we are going to connect it with the phase, and second leg we are connected with the neutral, single phase neutral line. Okay, and it has a 4 power devices. All the 4 power devices are controlled devices, SCRs. Let's say it is a controlled converter. Okay, and the load is resistive load. We are connected to the outer terminals of the rectifier. Okay, now the operation, we have the two modes of operation. Mode 1, okay, we are going to turn on 2 power devices. During positive off cycle, P is positive and neutral is negative. During positive off cycle, thyristor T1 and T2 are made forward bias, and we can give the pulses to these 2 power devices. And during negative off cycle, and this is negative and this is positive. Okay, T3 and T4 are forward bias, T1 and T2 are reverse bias. You can give the pulses to T3 and T4. Okay, in the mode 1, T1 and T2 are forward bias. We are going to give the pulses to these 2 power devices. Okay, and this is positive. The current flows through the power device T1 and load, and through the power device T2, and current is back to neutral. This is the current flow of mode 1. Okay, after receiving the pulses to the thyristor, the current starts to flow through the thyristor T1, T2 and through the load. Inside is a mode 1. In mode 2, this is mode 2, and this terminal is negative and this terminal is positive. Okay, and these 2 devices are forward bias. After the firing pulse, that is we are going to give the pulses after 5 plus alpha, these 2 devices are going to turn on. But these 2 devices are going to turn on, okay, the power flows from during second off cycle, this is positive. The current flows through the power devices T3, and this is made forward bias T3, and through the load, and the current is back to T4 and this terminal. This is the current flow of mode 2. For both the modes, current flows through the load in only one direction. Okay, that is why the input supply AC alternating quantity received in the R node as a single direction, that is a direct current. Okay, these are the two modes of operation. Now we are going to see the waveforms for the single phase full bridge converter. Supply voltage, what we are having the input supply, it's a single phase AC supply, single phase AC supply, then this is single phase AC supply, and the values of 0, that is a time period, that is a 0, pi, 2 pi and 3 pi, we have a single phase AC supply. Okay, and this waveform is for R load. Okay, the load is resistive load. If it is a resistive, the next one is R load with a discontinuous current mode. Okay, based on the inductance value, okay, we can have a continuous current mode as well as discontinuous current mode. Continuous current mode, the inductance value is high, then we can have a continuous current mode. And discontinuous current mode, inductance value is less, then we have a discontinuous current mode. Now we are going to see the RL load with a discontinuous current mode. Okay, discontinuous current mode, we are going to give the pulses that is during positive of cycle. We are going to give the pulses to the T1 and T2, considering the inductance is less. Okay, inductance is less. We are going to give the pulses at an angle of alpha. After that, the output voltage is going to get followed by supply voltage up to the value of pi. Okay, up to the value of pi. After that, the energy stored in the inductance, because of the inductance only, we are getting an output. Okay, there is output current. Output current starts increasing from the angle of alpha, start increasing up to the pi, that is pi. Okay, after that, what happens? The supplies get reversed. T1, T2 are get commutated and is turned off. Okay, what happens? The current starts reducing. The energy stored in the inductance gives the continuous current. Okay, but the current is become zero